Hi, my name is John Newton and welcome to my presentation. I work for HuaRay and today I'll be presenting our DWS solutions and how we can help automate logistics companies. In today's presentation, I'll cover the issues within the e-commerce industry, present our flexible DWS solutions, and go over some of our prominent successful installs in package delivery and warehouse centres. With the advent of the e-commerce platforms like Amazon and Alibaba, modern logistics infrastructure has been developing rapidly over the years. How to efficiently and cost-effectively deliver parcels to end users has become a common challenge within the industry. Annually in China, they've surpassed over 63 billion parcels in 2019. That means over 173 million parcels being delivered each and every day, with most end users expecting next-day delivery and some even same-day delivery. The Chinese logistics speed strategy means that nearly all domestic parcels are shipped within 24 hours and worldwide within 72, so an incredibly high demand on the network. Before automated solutions were available, mail and parcel delivery was handled manually or semi-manually, causing a huge bottleneck in the process, with parcels having to be manually picked, dimensioned and weighed. For the modern day output of logistics centres, this method of sortation and processing is not up to the level required to maintain high output and keep customer satisfaction. Even now, other factors still cause issues. The parcel identification information needs to be tracked and recorded throughout the whole transportation process. How to do this efficiently is a common challenge for logistics companies. Current challenges could include resource issues, so limited staff, especially at peak times, and again the ongoing increasing costs of those staff as well. Operational issues, so low efficiency, especially if it's being manually handled as well, manually weighed and checked. And again, the inevitable human errors that you get with the manual handling. Competition issues. As you get increased competition within the market, again, as those competitions start to automate, it means you're going to operate with lower profit. And again, with the resource issues, operational issues, again, that would drive down the profitability of the overall business. And then finally, satisfaction issues. So slow delivery to the customers, missing parcels where you've had human errors, or again, damaged parcels getting through to the end user as well. So our flexible DWS solution has been designed to meet those challenges head on. The system could be combined with multiple different types of technology to basically give the customer exactly what they're after within their specification. So in the next chapter, I'll go over the different types of technology, what we use, why we use them, different specifications available, and how you place that technology together to create the perfect system for your requirement. So in the first stages, we need to understand what the customer requirement is. We need to look at the following information: the process they need to achieve and where they want to deploy that particular technology. So whether it's in the early phases of the pickup or mini hub part of the application, whether it's in the central part of the application, so the large distribution centres, or the final part within the mini hub or micro logistics towards the end of the actual process. Then we need to look at the data acquisition, so what technology we need to use, whether it's purely going to be a barcode reading installation or barcode reading with a combination of different technologies like industrial machine vision cameras, 3D cameras, and scale weighing systems. When we're looking at the parcel as well, we need to work out what identification we need to take from that parcel. So the main area would be the ID of that parcel, and normally that would be a 1D or 2D barcode. The weight of the parcel, so using the dynamic scale or static scale to actually weigh the parcel. The 3D systems for basic sort of measurement or dimensioning of that parcel. And then finally OCR or optical character recognition, where we would use a industrial machine vision camera using an OCR algorithm to read human readable text or patterns within that parcel. After we've taken that data, we then need to understand what the customer wants to do with that data, whether they need alarm outputs if the barcode is missing, or if there's a highly damaged barcode on there, if the weight is over or the dimensions are over, again, how they want to output that data, again, whether they need like a reject chute to move that into a different lane within a conveyor, and then finally what systems we need to integrate into. So with all the information that we've taken, whether that gets put into an ERP or a warehouse management software, or again, if it's a simple device where they just simply want pure alarm outputs to be given. So a dimension weighing and scanning solution from ourselves would look something similar to this. So on the left-hand side here, we have a single parcel separator. What this does is takes the parcels or envelopes or packages in from the left-hand side conveyor that you see here. The parcels or packages would normally be all jumbled up, so on top of each other, without sort of equal separation in between each one. And what the separator will do is take each of those parcels, use our 3D cameras that are installed within there to actually identify the individual packages, and then use the technology underneath to then separate, place the parcels into a single file, and add an equal gap in between each of those parcels before it's fed into the scanning part of the application on the right hand side. On the right-hand side, we have the six-sided DWS solution. So this consists of 6 cameras and barcode readers, where we're able to take those parcels coming in and read the front, back, sides, top, and bottom for the code readers. Again, in there is our 3D dimensioning technology to actually dimension the package, and also our weighing system to also weigh the package as well. Both parts, single parcel separator and the DWS, are able to read about 3,600 parcels per hour. The belt speed normally is around about 1.5 meters, and on this solution, the belt width is about 1.6 meters. So with the HuaRay DWS system, we try to maintain a high specification for each part of the technology. With the barcode reading, we need to offer a large field of view, so 1.2 meters overall field of view for the code reading area. Again, a large depth of field purely because we're going to deal with different sizes of parcels, from something as small as a single envelope up to a large box or large package. So again, we offer a depth of field of about 800 millimeters, and this all needs to be read not only in the wide area and a large depth of field, but also at quite a high speed of 1.5 meters per second. With the dimension inside, we need to measure that parcel, and again, this still needs to be done at quite a high speed of 1.5 meters per second, and we also need to give a high degree of precision with the measurement as well, where the customer has to go back to their client to say that the parcel is an oversized. We need to offer that accuracy so they can feel confident when they go back to their customer to say the parcel was oversized for that particular shipment payment. So with the precision, we offer plus or minus 10 millimeters. And similar with the weight as well. Again, the customer needs to have confidence in the accuracy of the actual weight that we've given on that parcel as well. So the precision that we offer on that is plus or minus 50 grams. And then finally, the error output. So we need fast error detection and fast manual intervention. We need not to affect the actual process or line speed by dealing with that alarm output. So by combining these technologies, we try to offer sort of higher efficiencies. With the automation, we'll eliminate human errors, reduce the labour cost. Again, they're suitable for mass deployment, so if you have multiple sites, this can be formatted across lots of different sites. Maintenance is very simple, with hardly any moving parts within there, and the solution again is quite cost effective to roll out compared to manual labour. The main key component of any application within the DWS system is the barcode reader. So with the barcode readers, we offer a number of different types of readers that you can use within the application. Again, it depends on the barcode size, the line speed that you need to achieve, to what camera selection you'd need to choose for the barcode reading element of the application. So the entry-level sort of cameras that we offer would be sort of super VGA, so 800 by 600 pixels. Again, these would offer the fastest frame rate, so 60 frames per second. Again, the interfaces would all be Ethernet or Gigi on there. And then as we go up the scale, as you see, it's a trade-off of the resolution for basically the frames per second. The highest resolution that we do is the 20 megapixel camera. So again, you can deal with very, very small barcodes, cover a very wide area. And again, the 20 megapixel can be very useful for very small OCR human readable text that you may also want to read on there, but it does slow the process down, as you see there, down to about sort of 15 frames per second. On some applications, we also need to read the barcode on the underside of the parcel or package. Unfortunately for this, we can't use a standard 1D, 2D barcode reader or area scan barcode reader, purely because with the gap that we would need to introduce to get the full resolution of the camera on that parcel would mean that the parcel will either drop straight through if it's a smaller parcel, or get caught up and cause a hindrance to the rest of the packages coming through, thus slowing down the actual line speed. So what we need to use is what we call a line scan camera. And instead of using like an area CMOS, this actually uses a line of pixels across. The camera that we offer has 8,000 pixels or 8K across the actual line. And that can also be reduced down to 4K if you need a higher output to give you a sort of 2.5 meters per second line speed. The line itself, we combine that with an encoder, and what we do is as the parcel goes over the top, we use the encoder for the position, and we take slices or image slices of that parcel as it goes over, and we then build that image up as the parcel goes over the top, basically creating a very high resolution of that parcel, of that barcode. This allows us to give you a high degree of accuracy on the barcode width, so about sort of 0.2 millimeter, and again this can still be achieved at some pretty fast rates of 2.5 meters per second. The device itself is mounted to a frame, so you see by the image there that we have the camera on the left hand side. This fires the laser light through onto the mirror, which is then reflected upwards to the underside and through the gap on the conveyor. Another very important key component within any sort of barcode reading or machine vision application would be the lighting. You could have the highest resolution, best performing camera on the market, but if you don't have the correct lighting matched with that camera, you won't read the code, or you won't identify the target that you're looking to detect. So getting the right lighting for the application is very, very critical. So we offer a number of different solutions, and this is one of the solutions that we offer, which is our bright LED setup. So this actually has 48 high bright LEDs. Each of those LEDs has an optical lens over the front, which gives it a global uniformity of about 0.7. The lighting system itself is integrated into the camera, so the camera actually slots straight through, allowing the lens to poke through the front. The power is actually supplied to the light, which is then supplied to the camera. So what it means is you only need one power source to go directly into the light to power both the light and the camera as well. Again, the system has been designed so that you can adjust the lighting 180 degrees. So again, you can suit that for your application that you're working on as well. The next type of technology that you use on our DWS system will be our 3D cameras. This technology is not only used within our DWS solution, but it's also used on our parcel separator as well. We have two different types of technology that we use on these devices. So the top one would be our laser profile. So this actually fires out a laser line of light, similar to the line scan cameras. And what this allows us to do is with the line scan cameras, we only really get the X and Y information. But what this will actually do is also take the Z-axis information. So we basically get a full 3D image as the parcel or part is passed underneath the camera. This gives us a fairly wide field of view with the cameras. So we have about 1 meter by 1 meter by 1 meter. And it gives us a theoretical resolution of 5 mil by 5 mil by 5 mil on each of those parcels that go underneath. The system will generate a point cloud, and again we use our machine vision software to then take the measurements from that point cloud measurement on the application. The other technology that we use is slightly different. So instead of using like a laser line to get the X, Y, Z information, we start to use a twin camera system. So in the DS513, we actually use two cameras on the left hand and right hand side of the body with a central pattern projection, which projects a speckled pattern onto the actual target. We then look for the position of each of those dots on the parcel and distortion of the dots on the parcel to then get a full 3D image. This gives us a slightly larger field of view, so we're looking at 1 meter by 1 meter by 3 meter. Again, the system's performance is quite similar with 5 mil by 5 mil by 5 mil. Again, on the output of this, we can output a depth map, point cloud, and also a color map with the unit as well. and the working distance can be mounted from 500 mil up to 3.5 meters away. The system itself can deal with about 25 frames per second. So again, depending what the application is, whether it's high speed, high resolution, we can pick and choose what cameras we use on this particular solution. So as discussed earlier in the presentation, another key component to our DWS solution will be our parcel separator. So as discussed, this will actually take randomized parcels in from a third-party conveyor at a maximum speed of about 3 meters per second. It will take each of those parcels that could be all jumbled up on top of each other at different positions and basically separate each of those parcels and place them into a single file and give an equal gap in between each one before they're fed into the DWS scanning solution. The solution itself works with multiple 3D cameras built into it, which we basically take the X and Y information from the parcels. We also use sort of AI algorithms to identify those parcels and shapes, and then use the mechanical sort of sliders on the other side to actually introduce the gaps in between each of those parcels. The system has been designed to be pretty straightforward to set up and get working. And we try to do this at around about sort of 10,000 parcels per hour can be separated by this device. We aim for an accuracy of at least 99% parcels that can be separated correctly. And again, we can deal with very, very small parcels, so down to about 1 millimeter of height on that. The different types of parcels that we can deal with is very varied. So we can deal with high density small packages. So this would be envelopes or very small plastic soft parcels. And we can also deal with high density soft parcels. So where on the conveyor you've got a lot of jumbled up soft packaging parcels going through. Again, as you see the system, the units come in all jumbled up and then again are slowly separated as they go through the separator device. We can deal with high and low, so basically the very small envelope to larger boxes being mixed together. Again, the height's not an issue for that. Overlapping sacks, so we've got large bags of mail or parcels being placed on top of each other. We can individually separate those. Even if the packages or boxes are damaged, we're still able to identify those and again introduce the equal gaps. And then also overlapping of various parcel types, so where we have boxes, envelopes, soft parcels on top of each other. Again, the system is clever enough with the AI technology to identify those different packages, shapes, and identify the break positions and split each of those up via the separator. And again, still keeping that sort of 99% accuracy on that. So the last part of our dimensioning when scanning the solution would be our software platform. Our software platform gives an easy to read, easy to use communication between the DWS solution and the end user. This system can display barcode, real-time barcode information such as the decode rate of that production shift or overall production shift. Again, the amount of sort of no weights that have gone through. We can also tie the barcode information in with the weight, volume or measurement of the last parcel gone through. Again, we can display the image of the current parcels that are going through, or any sort of no reads or abnormal alarms that have gone through the system as well. The system can also support not only the DWS system, but also our standard barcode readers, as well as our rapid scan solution and fast hand presentation solution as well. The last DWS solution we have within the product line is our static DWS. This is a slightly unique piece of kit in the fact that this isn't a automated conveyor line. This would normally be installed at the early part of the delivery application. So basically where the customer is coming to a store from an office or wherever to basically send the parcel out. So the initial part of sending the parcel. The device consists of a weigh scale at the bottom of the device that the operator places the parcel onto. The top half of the unit actually has an embedded barcode reader and a dimensioning measurement system. The barcode will actually be read on the top half of the parcel, and the system will actually dimension the overall product length, height, and width, and then take the weighing information and tie that all together. The system comes with a face camera, so you can also take an image of the operator who loaded or weighed the actual parcel, and we also have a display screen and voice and light alert to communicate back to the end user. So basically communicating the process of what they need to do if you place the parcel onto the scale, leave the parcel, make sure the label is centered on the top, and then obviously telling them once the parcel has been finished for the weighing. And as I said, typical application scenarios would be sort of pick-up and delivery stations, again for offices that are sending out a large amount of parcels for the couriers to collect, that they can actually then dimension, weigh and scan the parcels before they're collected by the sort of courier. And also now we're seeing more and more sort of retail outlets like supermarkets having the option to actually send parcels from them as well. And again, these systems can be installed in those positions for them to again automatically dimension, weigh and scan those parcels before they're sent. In the last part of the presentation, I wanted to go over some of our success cases within the parcel and logistics area, giving you an idea of how the technology was used, the reason why some of the technology was also used on certain applications. The first successful case to go through was SF Express. SF Express took 500 six-sided DWS solutions from ourselves. These are deployed at a number of their sites and are used 24 hours a day, 7 days a week. The system was also combined with a panoramic HuaRay camera, and that was used to take a full image of each parcel. This was done so that the customer can actually use this for track and trace. So as the parcel come in, it would give an image to the end user to say that their parcel had arrived at the logistics centre. And it could also then be used for them to check the quality of the boxing as it started to leave the centre, to make sure that obviously the parcel wasn't damaged in transit in any way. Our next installation to talk about will be China Post. China Post took, again, more than 500 units across multiple China Post sites. This was a six-sided DWS solution with full 360-degree code acquisition. Again, you can see the flexibility of the solution fitting between the two conveyor lines. Our final installation would be Best Express. Best Express took over 1,400 five-sided dimension weighing solutions. Before they had this was a manual sortation, so they had people taking in each parcel and manually scanning, weighing and checking the dimension of each parcel, so it was causing a massive bottleneck within their process. By installing the DWS system, obviously this automated the process, and as you see, there's quite a lot of different sizes, shapes of packages coming through, and the systems are more than able to deal with that variation. Thank you very much for taking your time to view my presentation. If you have any questions on our DWS solutions or any of our machine vision or any of the other products within our product portfolio, please feel free to contact myself direct.